Hello students, so welcome to the class. In this class we are going to learn about recurrences. So recursion is a kind of reduction which can be described as follows. If the given instance of the problem is small or simple enough, just solve it. Otherwise, so reduce the problem to one or more simpler instances of the same problem. So what it means? So what is factorial of 5? So factorial of 5 I express as 5 into factorial of 4. So what is factorial of 4? I express 4 into factorial of 3. So what is factorial of 3? 3 into factorial of 2. So what is factorial of 2? 2 into factorial of 1. So what is factorial of 1? So factorial of 1 is 1. I know this. So this is the smallest instance of the problem, factorial of 5. Okay. So now coming to the definition, recursion is a kind of reduction which can be. So recursion is a kind of reduction. Here now we reduce the problem factorial of 5 to 5 into factorial of 4. Now factorial of 4 reduced to 4 into factorial of 3. Similarly, fact of 2, fact of 1. Now fact of 1 is small problem. Now so this we are going to solve. So what is the factorial of 1? 1. Now we return this 1 to this function. So 2 into 1, 2. Now this 2 is written to here. 3 into 2, 6. Now this 6 is written to here. So 4 into 6, 24. Now 24 is written to here. So 5 into 24, 120. Okay. So now if it is a small, it returns answer. Otherwise, reduce the problem to one or more simpler instances of the same problem. Fact 5 reduce it to fact 4. Fact 4 reduce it to fact 3. Fact 3 reduce it to fact 2. Fact 2 reduce it to fact 1. Now this we call as a recursion. So recursion is generally expressed in terms of recurrences. Okay. So when an algorithm calls to itself, that is recursive function, we can often describe its running time by recurrence equation, which describes overall running time of a problem size n in terms of running time on smaller inputs. So let us discuss with one example. So worst case running time, so T of n of the mid sort, substituted by recurrence can be expressed as T of n equals to, so big O of 1 if n equals to 1. Otherwise 2t n by 2 plus big O of n if n greater than 1. What it is? So this is the mid sort technique. In future classes we discuss about mid sort in detail. Okay. Now 4, 5, 6, 7, 8, 9, 10. Now the mid sort technique is we divide this array into two parts. So this is 10 elements. So 5, 5. Next this 5 is divided into two parts, 2, 3. Next we divide 2 into 1, 1. Now this is the smallest. We can't divide the one element array into two parts. So 1 is the smallest part. Now if n equals to 1, the time complexity is big O of 1. Okay. In all other cases, what we do? We divide the array into two parts, that is n by 2. Okay. So how many parts we are doing? Two parts. So 2t plus, so big O of n, we apply the same to all the elements. So it is big O of n. Okay. N equals to 1, it is big O of 1, and n greater than 1, it is 2t n by 2 plus big O of n. So now so this we call as recurrence relation. Okay. Now so for this mid sort, the solution is T of n equals to, so big O of n log n. So this is the time complexity for mid sort. Here you understand. So this type of equations we call as recurrence relations. So we have various techniques to solve the recurrences. So one is substitution method, iterative method, recursion tree method, master method. So next class we discuss about substitution method. Thank you.